Hello and welcome to Texas NSI's Acceleration in Mathematics continuing series. This is part one, where we will be talking about number talks, but the whole idea of these is to have some discussions around classroom strategies that you can use right now to scaffold that learning. Because as we talked about earlier this year, as we move from remediation to acceleration, when we get that just-in-time instruction, it's so very important that we have strategies that we can use in the classroom to help with that. My name is Mary Davis, and I am a hub improvement facilitator with the Texas NSI project from the Charles A. Dana Center at the University of Texas in Austin. So with that, let's go ahead and get started. We have two learning outcomes. The first learning outcome is more of a goal of the entire series. You'll see it over and over again, and that is to solidify an understanding of scaffolding and its role in acceleration. However, the second one will always change, and that is that we want to gain an understanding of number talk strategy in our first one today. So the first one, the important piece of it is that throughout this learning, we have to realize that our goal, our main goal, our end in sight is that idea of we want to make sure that we are accelerating the learning, that we are taking the kids where they are and helping to move them forward. Now, knowing that some of those kiddos will have some issues, some challenges, that's why we're talking about the scaffolding in our sessions. So instead of having norms when we meet virtually, we have community agreements. And you'll see these in every single one of our videos. The first one is come as you are. Look around you. Wherever you are, that is perfectly fine. Some of you might be sitting at a school desk or leaning back at a lounger at home or in the workroom or sitting by a pool. That would be nice. That's the joy of watching videos. You can come as you are right now at this moment. All that we ask is for that during this time that you really do kind of mute out the life around you and really focus on what we're talking about. The second one is learning is iterative. Learning doesn't take place in just a video or just a PLC meeting. Learning takes place over time. We are engaged in PDSA cycles with your campuses, and that really shows the cyclical nature of embracing a change. Well, any learning is a change, right? So that must mean that learning is also iterative. You can take what you learned today, go back, try it in your classroom. You might be really quick at it. You take to it right away. You might have to try it a few times before it becomes something that you can use. Invite others to a discussion over the material that you see. Invite them into your classroom to watch as you work. Go back and watch this video or others again once you have internalized it, and maybe you're going to see something else. Seems like every time that we watch a video, we do. So just continue to understand that you're not going to get it all in one little sit down of 15 minutes. You need to continue the learning since it is iterative. And finally, embrace the pause. There are going to be times during this video that I ask you to reflect on something before moving on. In that case, I'd like you to just pause the video and to think about it or to talk about it if you're with others. This is why pause buttons were created. However, there may be a time that you just want to go back and rewatch something. You might want to pause it and come back later after you try something. It is totally up to you how else you use that idea. But understand that without internalizing it, without pausing and reflecting, the learning doesn't stick with you. So really embrace the pause as we go through this. So I'd like to talk to you a little bit before we talk about math at all. I've been in enough classrooms. I taught for a lot of years. There's this idea about scaffolding with the students that some teachers, and I get it, I've been there, feel like I'm not going to hold their hand. They need to learn this on their own. I'm not going to give them a crutch to help them. I'm not, I mean, there's this negative feeling around having these strategies for the students to help them as they move through it. So instead of talking math first, I want to talk about riding a bicycle. Now, I don't have any kids of my own, but I have taught kids to ride bicycles. And this is how I did it the very first time. It was my niece, her name's Poppy, and I wanted her to ride her bicycle. So I sat her down, and it was at Christmas, and gave her a book that came with the bicycle that showed exactly where every part was, the handlebars, the pedals, the chain, everything about it. So she knew exactly every part of it. And then I explained to her that in the back of the book, there were these pictures of how to ride it. And so she looked through the pictures, and everything was great. So then I took her outside, I put her on the bike, and I shoved her. Yeah, that didn't really happen. You know, it didn't. But how many parents start their children learning to ride a bicycle that way? I truly believe you can say zero. I don't think there's one person out there that sits down and reads a book to learn how to ride a bicycle. You do it, you practice it, right? You get help when you need to. So instead, this is more like how we did it. For years, I had a bicycle with a seat on the back that she could ride, and she could watch me. So that's one thing. Then I had someone closer to her age, her older brother, that had been riding a bike for years, show her and explain some of the downfalls and pitfalls and how he learned and all this stuff. So she talked to her brother about it. So then, of course, I put on training wheels on the bike because I wanted her to have that stability. So I put training wheels on the bike, but as she started to learn, you can lift those training wheels up just slightly so she can start to get that balance. And I lifted them up every single time she was ready, until they really weren't touching the ground at all. And then, even then, when I took off the training wheels, I wasn't ready to let go of the seat. So I ran alongside her and held on until I was sure she was balanced and I'm sure she was ready. And then I let go. And she fell. And we got up and she tried again. That's what scaffolding's all about. All right. It's not about giving them things and giving them crutches that they'll never let go of. She rides her bike now all over the place. That's what scaffolding does. So I wanted to explain that and get that feeling of scaffolding before we move forward, because by implementing scaffolding, teachers can improve the likeliness that students will grasp new materials and retain what they've learned. So today's strategy, as I said earlier, is number talks. And number talks are designed to be discussing different strategies aloud with each other about something that they're doing mentally. All right. So the example that we're going to show right now, just to talk it through, is a subtraction problem, but it can be about anything. I mean, I could think about graphing. You could talk about the different parts of a graph. You could talk about equations and how you might solve an equation mentally. You could talk, I mean, there's like tons of different things. So we're going to talk through this one, and then I'm going to let you see part of a lesson where a gentleman is using a number talk to help students determine a function rule. So anyway, back to this problem. So I asked a number of people to mentally solve this problem and then to explain to me how they solved it. So it was really interesting because I got 6 unique answers. And I asked people all the way from those that were in elementary school for real, all the way up to my mother. And so I asked all different ways, and I just said, mentally solve it and then explain to me how you did it. So if you need to pause between each one before I explain it, feel free, get on that pause button, because I really want you to understand what they did. Because you kind of have to imagine a group of people talking about different methods. But here we go. The first one said, well, 70, oh, I'll stop. I was going to just immediately start talking. So the first one said that 75 was not so far away from 80, and 39 was really close to 40. So 80 minus 40 was 40. But then they had to realize that they had to adjust for what they did to get to the 80 and 40. So 75 to get to 80 was a plus 5. So they had to minus or subtract 5. And so 40 minus 5 would be 35. And that's this 40, the answer, not this 40, this 40. 40 minus 5 gave them 35. And then they realized that to get the 39, minus 39 to minus 40, that was actually taking one off. Remember, we're subtraction now, so we're on the other side of the number line. So they had to add one more back. And so 35 plus 1 would be 36. The subtraction kind of messed with their mind a little bit. In fact, we had to talk a lot about whether that should be a plus 1 or a minus 1, but we understood it at the end. So the second one, they said that they were just going to go ahead and use 75, but then 39 was not a number that they wanted to use. So they started to break it down, and they said, first, let's subtract the 30 off because that's easy. So 75 minus 30 gave us 45. And then there were still 9 more we had to subtract off. So although I believe that most of our kids could subtract 9 from 45 and get 36, this student said that 45 minus 5, because that's easy to do, 45 minus 5 is 40, and then 40 minus 4 was 36. So there's the 39 they subtracted off to get the 36. Okay, this one's very similar to the first one, only instead of to go into 80 and 40, they went to 70 and 30. So they went down on both of them. So in that case, then they had to adjust a little bit differently. And you can see that they ended up with 36. Yep, this was my mom's. I left it in there on purpose because although it's not a strategy that we could, that I would feel comfortable with elementary students saying, it is a strategy, and she got the right answer. We had a long talk about what she was actually doing. It was kind of interesting. I probably should have recorded that. But anyway, she said, you borrowed a 1 from the 7. And I was like, well, where's a 7? You know, I had to have her understand that she was actually borrowing 10. And so then she made 15 minus 9 to give us the 6, which is the 1's digit. And then 6 minus 3 gave us 3, which was the 10's digit. So a little more traditional way from a person that's been out of the math classroom for a while, but also a very interesting approach to it. I like this one, because this one doesn't have any, it doesn't look like there's any subtraction there at all. So what this person did was realize that if they started here and built their way back up, they could figure out what the answer was. So 39 plus 1 gave them 40. And then 40 plus 30 gave them 70. 70 plus 5 gave them 75. So that's your answer right there, the 36 in the middle there. And then finally, we had kind of an easy one here. Just simply said that 75 is an easy number to use as is. 39 is almost 40. We subtracted it, got 35, but we had to add the 1 back for the 40. And so it ended up being 36. So you can see, I mean, just imagine that this was a discussion and people have different ways, and we've got discussions going about how this works and how this works and why does this work, and you know, that whole conversation going. I mean, think about the power of seeing all these different approaches. Even this one that I said that, you know, it was more of a traditional approach. How many kids do you have that you show them a way at school, or you discuss different strategies at school, and then they get home and their parents show them the correct way to do it. And you can't see me, but I was putting that in air quotes. And the students don't understand how the two connect. So this is a great way for them to see different strategies and to talk about the math. And you can actually get a lot of information. Talk about formative assessment. You start talking like this, you can find out a lot about what the kids know. So we're going to go into a classroom now. And in this classroom, this man, his name is Fran Dickinson, and he is going to talk about, it's just a what's my rule type activity where they're talking about input and output, and he's having them guess what the rule was. And in the first part of the video, the students got those first three numbers. They were able to pick numbers 10, 6, 8, all sorts of them. And he gave them the output. Then he started to say, hey, do you think you got it? They were all like, oh, yeah, we're sure we got it. In fact, some of them you can hear him whispering, times 3 minus 3, times 3 minus 3. But then he threw this out. He said, without telling me what it is yet, can a Y output be 0? And he stopped, and half the kids were going, no, can't be. Because they were seeing that every single one over here is smaller than the numbers here. And if this was 0, they were thinking this had to be less, and X could only be between 0 and 10. But that's where we're coming into this conversation. The kids are talking about, can this be equal to 0? Why or why not? Now, I wanted to let you know, while I'm changing over to the video, I wanted to let you know that the transcript of this video has been provided for you. Now, the reason that it was provided is in the very beginning, especially, the kids are kind of talking over each other. It's a real class, so I'm just going to warn you. And so some of the discussions, it's a little bit difficult to hear. So you might want to download the transcript, or you can just watch it and listen. What I would like you to do is to think about this question as we go through this. How can engaging in number talks help scaffold accelerated instruction to my students? How can engaging in number talks help scaffold the accelerated instruction, that just-in-time learning, that not the review, we're not going to review them all, we're going to keep them up to grade level. How can that help scaffold accelerated instruction to my students? So with that, let's go into the classroom and see them talking about it.
I think it's x times 3 minus 3. So x 3 minus 3, yeah, because then, yeah, it would work. Yeah, it works. No, anything. Minus 2 would be negative. Because times 2. Yeah, so 3 times 0. Then minus 3 going to negative 4. Yeah. No, although I really said 0. I said 0 to be I think I understand where you're coming from. Yeah, like where I thought it to be the lowest, you know, that's kind of fun. Yeah. Wait,
are you agreeing?
I would guess 0 as the eighth grade. That would be that's my ninth grade. Yeah.
So tell me, what were you hearing at your table? Kristen, what did you hear at your table?
Well, we thought that it could work because their parameter was greater than or equal to 0.
All right. Christina, what did you hear at your table?
Well, we thought it wouldn't work because, well, we think it would be -3 instead of 0. Like, we didn't think that 0 would work.
What would be -3? Can you be more
Well,
specific?
It's just it would be the Y the output, because 0 would be possible.
0. So let me get some clarification now. So Griffin's guess was Y, his guess was a Y value. He guessed 0. So maybe I should write that on the board here. So, and my question to you was, is this possible? So I asked a very vague question there. What do you think, Robbie? Sorry.
Well, because I kind of noticed this is because the Y and everyone is bigger than the X. And your parameters say that X has to be greater than or equal to 0. So if the X is smaller than the Y, it can't be smaller than 0, so that wouldn't work.
Can someone put in their own words what they hear Robbie saying? Kylie.
In all the numbers we've done so far, the Y will be bigger than the X. So if the Y is 0, then X would have to be lower than 0. But the parameters of the X have to be equal to or greater than 0. So
I see that I have some comments around the room. Eric, would you like to make a comment?
I think, I think the X would be.
Sure.
I think it'd be 1. Because the other one to look at X is minus the means. I and 1, so 1 times 3 is equal to 3. Minus 3 is 0. So I thought it would work.
I heard some ahs. Did I hear that somewhere? I see some agreement around the room as well. Teo, what are you agreeing with?
I'm agreeing because we talked about the same thing at our table. Because I was thinking negative at first, but then I saw it was a Y value, not the X value. So then I thought, I don't know. And then Griffin told me what he was thinking about what he said. So
Very good.
I understood.
Can I see agreement in the room or disagreement? This point here is 1, 0.
All right, so as I change back over to the other screen that I was using, you might have noticed a few things. He used some visuals, like their hands beside their head saying yes, or you could see them crossing their hands saying no. So routines and things like this can help with the organization of a number talk. So I just wanted to point that out. But deeper than that, remember your question was, how can engaging in number talks help scaffold accelerated instruction to my students? So I'd like you to pause for a moment here. And if you're with people, have a discussion about it. If you're by yourself, reflect on it, maybe write a couple things down before you continue to the next slide. All right, welcome back. So some of the answers that I've gotten when we did this in person to this question, how can engaging in number talks help scaffold accelerated instruction to my students? One person really talked about the fact that it allows all students to contribute. No one is when that one student said that the answer would be -3, it wasn't that everybody screamed no at that student. It was a suggestion. You noticed he didn't even say yes or no. The other students had to either agree or disagree and why. So remember that norm that we always talk about when we're together about mistakes are inspected, respected, and expected. Well, that can really help with the discussion as well. So they're all able to contribute. Some may only be at a basic strategy and some may be higher. So it may just be that one person could share that they knew that the parameters of this problem was between 0 and 10 for the X. If that's all they can share, that's great. It's a true statement. They've contributed to the discussion. Someone else said that they can see how students are thinking. Formative assessment is a big piece of number talks. You can see how brains are working, how things are going. So it's really kind of a neat approach to thinking about it. And then someone else, as we talked about this, said that it is scaffolding because we are giving them other ideas, other strategies. So that's where the scaffolding part comes in to help support them. but it is also formative assessment because you are also looking and thinking about what they're responding to each other and to your questions to the group. So hopefully you came up with some of these or maybe some others, but getting them to talk in the classroom is a huge piece. And it doesn't have to be about their homework or some huge task. This was kind of a game, you know, what's my rule? Pick it out. So our learning outcomes today, just as a reminder, we were going to talk about scaffolding some more. So we did that at the beginning. And then we kind of got a better understanding of what number talk strategy is all about. So I wanted to remind you that there's 3 other videos in this series: visual aids, error detection and correction, and collaborative placemats. Thank you so much. Don't leave yet. Please do not leave yet, because there is a quick exit ticket. But I did want to point out that if you had other questions about number talks or any other math related queries, I work with Crowley ISD mainly, and we have Jackie and Mike in Richardson ISD. So please feel free to take these emails down and reach out, and we will be glad to talk to you more about number talks or anything else you might have a question about. So before you go, if you could please scan this, or else I made a tiny URL that's pretty straightforward: Texas NSI Scaffold. It is an exit ticket. It's the same exit ticket every single time. You just have to say which of the sessions that you're in. And this is session 1, which is all about number talks. So leave this screen up there as long as you need to, and we'll see you on the next video. Thank you so much.